What if the loneliest machine in the universe just sent us a message that scientists cannot fully explain? 4 minutes ago, a signal left a spacecraft so far from home that nothing about it should still be working. And yet, it is still talking to us. Before we go any further, hit that like button right now, because this is the kind of story that deserves to be seen by more than just a lucky few. Subscribe if you are new here, and share this with the one person you know who still looks up at the night sky and wonders what is really out there. Let's get into it. In 1977, a small machine left Earth on a rocket. It was never supposed to become famous. It was never supposed to become a legend. Its job was simple. Fly past a couple of planets, take some pictures, send back some numbers, and then fade into silence like every other spacecraft before it. Engineers gave it 4 years, maybe 5 if it was lucky. Nobody in that control room in 1977 imagined they were building something that would still be working, still exploring, still surprising us decades into the future. That machine is called Voyager 1, and nearly 50 years later, it has done something that no model, no simulation, and no scientist ever fully predicted. It has shown us that everything we thought we understood about the space beyond our solar system might be incomplete. Here's the part that makes this different from every other space story you have heard. This is not a telescope looking at something far away. This is not a computer simulation guessing what might be true. This is an actual physical object, sitting right now in a region of space no human instrument has ever occupied before, sending back real measurements from a place we could previously only imagine. And what it is telling us is stranger than fiction. Let's rewind for a moment, because to understand why this matters, you need to understand where Voyager 1 actually is. Our solar system is not just empty space with planets floating around in it. The sun constantly blows out a stream of charged particles in every direction. This stream is called the solar wind, and it forms a massive protective bubble around everything we know. Every planet, every moon, every human being who has ever lived, all of it sits inside this bubble. The edge of that bubble, the point where the solar wind finally loses its strength and gets pushed back by the pressure of the space between stars, is called the heliopause. Think of it as the actual border of our solar system. Cross it, and you're no longer in our neighborhood. You're somewhere else entirely. In 2012, Voyager 1 crossed that border. It became the first human-made object to leave the solar system and enter true interstellar space. Not close to it, not near it, inside it. For thousands of years, every single human being who ever lived looked up at the night sky, from inside that protective bubble. Every explorer, every philosopher, every scientist who ever wondered what lies beyond our world was, without exception, still standing safely inside the sun's shield while they wondered. Voyager 1 is the first thing built by human hands to actually leave that shield behind and step outside of it. And it kept transmitting. Think about what that actually means. We have a working instrument sitting inside the space between stars right now, not a photograph, not an estimate, a live machine physically present, measuring what that region of the universe is actually like from the inside. For decades before Voyager 1 got there, physicists built careful models predicting what interstellar space should look like. These were not wild guesses. They were built on real math, tested theories, and years of careful work by brilliant people. And almost all of those models agreed on one thing. Interstellar space should be calm, thin, quiet. A slow, cold, mostly empty region where very little happens. Voyager 1 arrived and found something completely different. Starting in 2017, an instrument on board began picking up a strange, steady signal. Not a one-time spike. Not something that could be explained away as a glitch. A continuous hum in the plasma of interstellar space that kept showing up year after year, stretching across hundreds of millions of miles. To put that in perspective, the distance between Earth and the Sun is about 93 million miles. This strange signal has now been detected across a stretch of space nearly 10 times longer than that entire distance. Scientists studying this data have said plainly that interstellar space is not the smooth, quiet place the old models described. It has structure. It has motion. It behaves less like empty silence and more like an ocean with currents running through it that we never knew existed. Sit with that for a second. Every idea we had about the space beyond our solar system was built by people standing on Earth, using telescopes and equations to imagine what was out there. Now, for the first time, we have an actual witness inside that space. And that witness is telling us the story we wrote was missing pages. Think about how strange that really is. We have sent rovers across the surface of Mars. We have flown probes past every planet in our solar system. We have photographed galaxies so far away that their light left them before our own planet even existed. And with all of that, the most basic question about the empty space just outside our own front door, whether it is calm or turbulent, still had the wrong answer written in our textbooks until one aging spacecraft physically flew into it and reported back the truth. That is the part that should stop you in your tracks. It is not that we lacked imagination. It is not that our scientists were careless. It is that some truths about this universe simply cannot be reached through calculation alone. Some truths can only be collected in person by something that is actually there, patiently gathering data one measurement at a time for years without complaint. But here is where this stops being a distant curiosity and becomes something personal. That protective bubble around our solar system, the one Voyager 1 had to cross to get outside, is not just a boundary on a diagram. It is a shield. It blocks a large amount of dangerous cosmic radiation from reaching the inner solar system, including Earth. If that shield behaves differently than we assumed, if the environment pressing against it from the outside is more active and more energetic than our models expected, then the thing standing between us and the harshest radiation in the galaxy might not work exactly the way we thought it did. We do not know yet exactly what this means for the long-term safety of life on Earth. But the fact that serious scientists are now asking that question at all tells you how significant this discovery really is. There is a second discovery, hiding inside this one, and it is just as strange. For decades, scientists assumed that crossing the heliopause would feel like crossing a clean line. Inside the bubble, the sun's magnetic field. Outside the bubble, the separate magnetic field of the wider galaxy. Two different systems, cleanly divided, like stepping from one room into another through a closed door. That is not what Voyager 1 found. Instead, it detected signs that the sun's magnetic field and the galaxy's magnetic field are not cleanly separated at all. They appear to be linked, reaching into each other at the boundary, exchanging energy in a process physicists call magnetic reconnection. In simple terms, our solar system is not sealed off from the rest of the galaxy the way we assumed. There's a quiet, constant conversation happening at the edge of our home, one that nobody knew was taking place until a single spacecraft flew directly through it. That is not a small correction to a textbook. That is a sign that the wall protecting us might be far less simple and far more dynamic than anyone had imagined. And the story does not stop there, because in 2023, Voyager 1 nearly went silent forever. For 5 months, the spacecraft kept sending signals back to Earth, but those signals made no sense. It was not silence, it was static. Garbled, unreadable code that engineers who had spent their entire careers reading this machine's data simply could not decode. The spacecraft was alive. It was trying to speak, but whatever it was saying had turned into noise. When engineers finally traced the problem, they found something almost heartbreaking in its simplicity. A single memory chip inside the spacecraft, a tiny piece of 1970s hardware, had quietly worn down after nearly 5 decades of constant exposure to cosmic radiation. No warning, no alarm, just one small part, slowly failing after being asked to work far longer than anyone ever expected of it. Now imagine trying to fix that. You cannot send a technician. You cannot mail a replacement part. The nearest tool available is a radio signal traveling at the fastest speed physically possible in this universe, and it still takes over 22 hours just to reach the spacecraft. Another 22 hours for any reply to come back. Every single test, every theory, every attempted fix took nearly 2 full days just to complete one round of communication. Picture that process. You study the data, you guess what might be wrong, you write new instructions, you send them out into the dark, and then you wait. A full day passes. The response arrives. It is not quite what you expected. You adjust your theory, you try again, and you repeat that over and over for months, knowing that one wrong command sent across billions of miles could end everything permanently, with absolutely no way to undo it. Think about what that kind of pressure actually does to a team. These were engineers who had spent decades of their careers listening to this one spacecraft. Some of them had built their entire professional lives around understanding its quirks, its habits, the small ways it behaved differently from its twin. And suddenly, the machine they knew so well was speaking in a language none of them could recognize anymore. There was no manual for this. Nobody had ever tried to repair a computer chip nearly 50 years old, sitting 15 billion miles away, using nothing but patience and radio waves. The team did not panic. They worked the problem piece by piece, month after month, with a level of patience that is hard to imagine in any other field of engineering. And eventually they solved it. They could not repair the damaged chip, so instead they found a way around it, splitting the affected code into smaller pieces and tucking them into other parts of the spacecraft's limited memory, rewriting each piece so it could still function from its new location. It worked. In the middle of 2024, Voyager 1 came back online, sending clear, readable data once again. And almost immediately, it went right back to reporting more of that strange, unexplained activity in interstellar space. The machine that should have died in 1981 had now survived a crisis that could have ended it in the 21st century, and it came back with more questions for us to answer. If you have made it this far, I want you to comment one word below that describes how this story makes you feel. Curious, small, amazed, uneasy, anything. I read these, and I want to know I am not the only one who finds this genuinely unsettling in the best way. Now, let's talk about what is happening to this spacecraft right now in 2026, because the ending of this story is already written into the calendar. This is not a battery you can recharge, and it is not solar power either, since sunlight this far from the sun is far too weak to be of any use. Voyager 1 runs on power generated by the slow decay of plutonium inside 3 small devices on board. At launch, these devices produced around 470 watts of power. Today, nearly 50 years later, that number has dropped to roughly 250 watts, and it keeps falling by about 4 watts every single year. At some point in the early 2030s, there simply will not be enough power left to run any of its remaining instruments, and Voyager 1 will go permanently silent. The team responsible for this mission has known this day was coming for years. They have spent that time making some of the hardest decisions in the history of space exploration, choosing which scientific instruments to shut down and in what order, trying to squeeze every last useful measurement out of a dwindling power supply before it disappears completely. Of the 10 instruments Voyager 1 originally carried, 7 have already gone dark. Each one that gets switched off represents questions about the universe that may never be answered, because there is no way to turn an instrument back on once it has been shut down for good. Imagine being the person who has to decide which instrument dies this year and which one gets to survive a little longer. There's no way to bring an instrument back once it has been switched off. Every decision is permanent. Every choice closes a door that can never be opened again. That is the quiet, unglamorous heartbreak sitting behind every headline about this mission. Nobody is fighting aliens or dodging asteroids. They are simply trying to say goodbye to pieces of a machine they love, one instrument at a time, as gently and as usefully as they can. But here is something most people do not know. The team has not given up. Engineers at the lab, responsible for this mission, are currently testing an experimental method for redistributing power across the spacecraft's remaining systems, trying to pull extra electricity out of components that are not currently running at full efficiency. It is risky. Any small mistake in how power flows through a machine this old with no way to physically inspect or repair it could cause unpredictable damage. So they are testing this method first on Voyager 1's twin, Voyager 2, which has slightly more power to spare and sits somewhat closer to home. If those tests succeed, there's a real chance that one of the instruments already shut down on Voyager 1 could be switched back on. Nobody on the team is making promises, but they are trying, because with this particular spacecraft, betting against it has never once paid off. Quick pause. If you have a theory about what that mysterious signal really is, drop it below. I genuinely want to see what you think, and I will pin the answer that comes closest. Now smash that like button if this is blowing your mind the way it is blowing mine, because what comes next is the part almost nobody talks about. And now for the date that changes everything. On November 18th, 2026, at a precise moment already calculated down to the second, Voyager 1 will reach a distance of exactly 1 light day from Earth. That means a radio signal, moving at the fastest speed anything in this universe can travel. Will take a full 24 hours just to reach it. Send a message on a Monday morning, and you will not know if it even arrived until Tuesday morning. You will not hear back until Wednesday. 2 entire days, just to complete a single exchange of words with a machine we built with our own hands. No human-made object has ever been that far from home. Not once, in the entire history of civilization. And Voyager 1 will cross that threshold while it is still alive, still listening, still speaking back to us across the dark. Stop and really picture the scale of that for a moment. Light is not slow. It is the fastest thing that exists anywhere in this universe. It crosses the distance, from the sun to the Earth in about 8 minutes. It could circle the entire planet 7 times in a single second. And yet, by this November, that same impossibly fast light will need a full day just to cross the gap between us and a machine we built in a factory on Earth. We are not just talking about a spacecraft that is far away. We are talking about a spacecraft that is redefining what far away even means for our species. After that, it just keeps going. Every hour adds roughly another 38,000 miles of distance. The delay keeps growing. The power keeps shrinking. And sometime in the 2030s, the very last signal will leave the spacecraft, take its long journey home, and arrive here on Earth. And then there will be nothing after it. But Voyager 1 itself does not stop. There is nothing out there to stop it. No air, no friction, no gravity strong enough to pull it seriously off course. It will simply keep moving in a straight line, silently, forever, long after the last engineer who ever worked on it has passed away. And bolted to its frame is something that will outlast us all. A golden record, carrying greetings recorded in 55 human languages, the sound of rain, the sound of ocean waves, the sound of human laughter, 90 minutes of music chosen from cultures across our entire history, and a simple map showing exactly where our small world sits in this galaxy. Whoever or whatever eventually finds it, whether that happens in 100 years or 100 million, will learn one simple truth from it. Something lived here, Something built machines and sent them out into the dark, carrying nothing more dangerous than the sound of its own laughter. That record will still be drifting long after our sun eventually swells and swallows Earth's orbit. It will still be traveling after every city, every book, every name we ever carved has turned to dust. It might be the single most permanent thing our entire civilization has ever created. And right now, it is riding on a machine that runs on less power than your refrigerator light bulb. There is something almost unbearably human about that choice. Out of everything our species could have sent into the dark, the scientists behind this project did not choose weapons or borders. They chose laughter. They chose music. They chose the sound of a mother greeting her child. Whoever finds that record someday will not learn what we fought about. They will learn what we loved. And maybe that says more about who we really are than anything else we have ever built. It is worth remembering that the people who built the golden record never expected to be alive when or if anyone ever found it. They built it anyway. They spent months choosing sounds and images and languages for an audience that might never exist, on the small chance that one day, somewhere, someone would listen. That is not really a scientific decision. That is an act of pure hope, sealed in gold and sent into forever. There is still one mystery at the center of all this that nobody has fully solved. That strange, steady signal Voyager 1 has been picking up in interstellar space since 2017 has two possible explanations, and scientists genuinely do not yet know which one is correct. It might simply be plasma vibrating naturally as it interacts with its surroundings, which would be significant but still fit within physics. Or it might be something else entirely, a different kind of signal that would force us to rewrite parts of what we thought we understood about the space between stars. Answering that question requires either more data from Voyager 1, which is producing less every single year, or an entirely new mission built specifically to study interstellar space. No such mission exists. No such mission is currently funded. If one were approved and launched today, it would take at least 25 years just to reach the boundary Voyager 1 already crossed back in 2012. Which means, when Voyager 1 finally falls silent, this question stays open. The only real window humanity has ever had into the space between stars will close, and it may stay closed for a generation. Think about how unusual that is in modern science. We live in a time when most mysteries get solved fast. Someone builds a better telescope or a faster computer, and the gap in our knowledge closes. This one is different. This mystery might sit unanswered for decades, not because we lack intelligence, but because we lack a working machine in the right place to finish the job. The bottleneck is not human cleverness. It is simply distance, time, and a spacecraft running out of both. Here is what I keep coming back to when I think about this story. Right now, in 2026, the only living scientific instrument our species has ever placed outside our solar system bubble is nearly 50 years old. It was designed with less computing power than a modern calculator. It runs on a trickle of electricity that would barely light up a hallway. And it is quietly rewriting parts of what we thought we knew about the universe we live in. We have built bigger machines. We have built more advanced machines, more expensive machines, machines with more sensors than the engineers of 1977 could have ever dreamed of. And none of them have told us what this one small aging spacecraft is telling us right now. Because none of them had the one thing Voyager 1 had. They never got the chance to actually go there and stay long enough to listen. Some questions about our universe can only be answered from inside it, not from a telescope, not from a satellite circling our own planet, but from something that physically crossed the line. Right now we have exactly one machine that has done that. It is old, it is fading, it is running on almost nothing, and every single day it keeps transmitting is a day we keep listening to a place we may not be able to reach again for decades. The signal is still out there right now, stretched across billions of miles, arriving faint and delayed, carrying proof that the universe beyond our home is stranger, more alive, and more connected to us than we ever fully understood. And maybe that is the real lesson hiding inside this entire story. We spend so much time imagining that the biggest discoveries will come from the biggest machines or newest technology. But the most important lesson of the last 50 years might be the opposite. Sometimes the discovery does not come from building something new. It comes from refusing to give up on something old. It comes from a small, aging machine that nobody expected to matter this much, still doing its job long after everyone assumed its story was finished. One small machine. Barely any power. One last chance to listen before the silence comes. If this story stayed with you, do not scroll past it in silence. Tell me in the comments what part surprised you the most. Hit subscribe so you do not miss what we uncover next. And send this to someone who still believes there's nothing left to discover about the universe, because clearly there still is.